Welcome back to Where It Makes Sense. So now we're going to talk about line graphs. Line graphs is the most used in ABA. One of the reasons is because it allows us to make a visual, meaning we're going to use our eyes, analysis. It can tell us what by looking at the graph, kind of what's going on, depending on what we're measuring. Okay? So line graphs is the most used in ABA because it allows for a visual analysis of what's going on. So the whole purpose of this video is to talk about these parts, what makes a graph. So let's get to it. So we'll need to make sure we know the title, the x-axis, the y-axis, the data point, the data path, condition line, and a condition label. So let's start. This line that goes down, this is your y-axis. The horizontal line is your x-axis. Now on here you can have your date, years, sessions, basically time. Okay? Your y-axis is used for your measurements. Now, is it any old measurements? Are we talking about like yards and feet? And it could be used for that, but ABA is used for your continuous and your discontinuous measurements. So what are your continuous measurements? Can you give them to me? So you should say frequency, duration, rate, IRT, and latency. And discontinuous is whole interval, partial interval, momentary time sampling, and when you can count the permanent product, and sometimes the play check, which is still kind of a momentary time sampling, but you need to know that. So remember that your y-axis has to do with your continuous and your discontinuous measurements go on this line. So if you're going to do percentages, frequency, they're on your y-axis. Okay? Now, it's very important that you know what you're measuring. So let's say that we're measuring hitting. Okay? Now let's just do sessions. Session 1, 2, 3, 4, 5, 6, 7. And then we have these little points. The single point is called a data point. Just it by itself, that one little tiny dot that's all by its lonesome. When it's more than one, I like to change here. This area that's in between them is called a data path. So then from this dot to this dot, or you can even say, let me just make it even really simple, from all these dots form a data path. To have a path, you need more than one dot. You got it? Good. All right, so one point by itself is one dot is a point. More than one dot is a path. All right? There's something called a condition line, which would run straight up and down. Okay. This line is a condition line. The reason it's called a condition line is because something has happened within the treatment. So we're running a treatment and something has changed. Well, in order to know what that something is, you're going to have a text box. If you're graphing, you'll know to click text box so that you can write inside it. But it's called a condition label here. And we're going to say they had a 5 milligram increase important that we know what this is because the condition line, you're going to look at what happens before this line with the data points, and you're going to look at what happens after the line. Before the line and after the line, you're looking at the points. Basically, this condition line, if it was a real case and we're looking at it and they had a 5 milligram increase of Adderall and they were hitting, we'd see that the behavior didn't really change, and then all of a sudden we have an increase. So it's kind of an assumption that I don't think that Adderall is working. It just might not be working. But technically, if you're looking at it from this point, what we would do is make another condition line, and we would just remove the Adderall. Go back to baseline. We go back to see if it goes back or if it decreases. And then we know for sure that the Adderall did not work. But I took it a little further than what I should have and got to talking about reversal designs. But I'm going to keep it simple because none of that will concern you right now, unless you do your BCABA or your BCBA, which I hope you do. But for right now, the only things that we needed to know that the line graph allows for visual analysis, that we have a y-axis, we have an x-axis. The y-axis has our measurements, x-axis has our date, years, and sessions. We need to know that we have 1 point equals a data point, more than 1 point equals a path. We have a condition line that will come anytime there's a change in the treatment, and there's a box, a condition label to tell us what that change was, and you have a title of what your graph is. Okay? Okay. So I wanted to show you one quick thing that's important. Really quick. I don't want to take up too much time. It's late here. So let's just make this fast. I like to see if you can interpret the graph before I let you go. When you get a graph, it's usually something like this. It's not going to have y-axis on there, x-axis. It's just assumed that you already know what that is. Okay? So, bear with me, hang in there. I'm going to show you something that may help you. Okay, I have two different graphs here that I want you to look at. All right, so on the top graph, we have our y-axis and we're measuring frequency. And what is frequency? It's a count, how often it's happening. But what are we measuring? Hitting, all right? So these 2 days, we knew that hitting was occurring from 25 to 30 times within that whole day, okay? Then we added a DRA, right? Oops, I did this backwards. Okay. We added a DRA, and then once, right here is where the DRA. What is a DRA? Differential reinforcement of an alternative behavior. Remember? Okay, if you don't, you want to go watch the behavior reduction slides. But we've added this DRA here, and we're still looking at hitting. So we noticed that hitting went down to about 24, then it dropped to 20, then it dropped to 10. So we can kind of look and say, oh, the DRA just looks like it's working. It looks pretty good, right? Well, here, the other thing you want to make sure that you do, if you have a DRA, you want to take the time to compare it. So our DRA was asking for an item. So obviously they must have been hitting when they couldn't get what they want. So we're asking for an item. Here you see what we would consider like a baseline. This is where their asking was. It was already in their repertoire. It just wasn't being reinforced, which means that they could do it every now and then. But if they hit and got the item faster, that's what they were doing. It wasn't receiving reinforcing for asking. So a DRA says what? Just gonna tie it all together. So you have a DRA. We have 2 conditions. What are we telling the difference between? Our target behavior, remember, which is hitting, and our replacement behavior, our alternative behavior. So instead of hitting, we are asking for an item. We're going to reinforce this one. That's where the reinforcement comes. And we're not reinforcing this one. That's through DRA. So here you see that once we added the DNA, the DRA, once we added the DRA, put the dates real quick, you could see 30%, 40%, 60%, you could see it increasing. The thing that I'm trying to show you is you need to compare both situations. If hitting is going down, then your DRA or your alternative behavior should be going up. If for some reason your alternative behavior is going down and hitting is going down, then this was not the factor that affected the behavior. It was something else. And this is a lot of times, if I can look at it and remember, if it's going down, then it's not the factor that affected it. A lot of times, if I'm studying my graphs, and you don't have to look at your graphs every day, but I would say look at them at least like maybe every 2 weeks, once a month at least. If I see this happening over a couple of days, it's going down, and I'm like, well, it's not the DRA. A lot of times it will prompt me to call the parent and ask, hey, did anything change? Because I know it's not the procedure I put in place that's making it go down. And guess what? A lot of times they'll tell me, oh, we started a new medication. I forgot to tell you guys that we put them on medicine. So the medicine would be contributing to this, not the treatment. So I just wanted to show you how graphs work both ways. And to make sure that anytime you are interpreting a graph, you're interpreting both graphs, not just hitting by itself, but making sure that they're correlating. If there's not a correlation that one's going down and the other one's going up, then there's something wrong, and you may need to remove or add another variable or do a little research to find out what's going on. But again, I took you a little bit further past the RBT because I do want you to think about what you're doing and if it's having a positive effect on your client. So just for the RBT, just remember you need a title. You need to know where your x-axis is. You need to know that this is your y-axis. You need to know that one point by itself is a data point. You need to know that this is a data path. The multiple points equal a path. You need to know that there's a condition line, and inside that condition is going to tell you what changed in the treatment. Here we added a DRA. It changed the treatment instead of medication. But whatever the change is, it would go there. But these are the most important things that you would need to know for your RBT area in interpreting the graph. I hope you enjoyed it. If you have any questions, write them down, or you can send them to mentoringbehavioralservices@gmail.com, and you will receive an answer. Have a great day.